There you go. Sphere Factor. Welcome to Sphere Factor, the game show where contestants test their knowledge about pastimes that use spherical objects. To win, all you have to do is have a pretty good knowledge of physics. But don't get worried too much because there will be fabulous prizes for all of you. Well, for the winning table, okay? So here's how the rules are going to work, okay? At your table, you all can find a little personal response remote. It looks like this, okay? And you're going to ask one person. One person at the table is going to be in charge, and they're going to be the answer giver. So give them the remote now. Okay? We're going to pose a bunch of questions for you based on some scientific demos, and we'll just ask you to press the coordinating number or letter to the questions, and they'll be listed up on the slide for you so that you know. So first, we'll pose a question based on a demo, and the answer giver is the only person who can answer. They'll click in. But then we will allow for table discussion. So you can discuss and then change your answer if you want to. Then we will, and while you're doing that, you want to make sure that you're questioning your reasoning. Like, not only do I think it's going to do this when they do the demo, but why is it going to do that? Because we're also going to ask you a question about your reasoning behind your answer. And the person or the table with the most amount of points at the end of the evening is going to win a fabulous prize. All right. So the first demo is called the bowling ball of doom.
Okay, so you see here, and how this demo is going to work is I'm going to put my life on the line here, quite literally. What I'm going to do here is I'm going to take this bowling ball, and I'm going to bring it up, and I'm going to hold it right near my face here, and then I'm going to let it go. And I'm going to let it go, and we're going to see what happens, basically. So if you could go to the next slide, I'll show you. So here's your question. I'm going to hold the bowling ball up, and I'm going to release it from rest right in front of my nose. And then when it returns back, so obviously it'll swing to the other side and come back, I want to know what's going to happen. So in the first case there, is it going to stop well before reaching my nose? So maybe, significantly. Is it going to stop shortly but noticeably before reaching my nose? Is it going to get to right where I released it from? Or perhaps the one you're all rooting for, which is that it will smack me in the face. So I think at this point, we got to see what's going to happen now, right?
Yeah, okay. I'm going to help you. No, just back it up. Just all the way. Can you just start where your teeth are about? Can you? Yeah, okay, right about there. Let's do it from there, okay?
I don't know how I feel about this anymore. Maybe we should, I got a good idea, hon. Just hold that. Is that better?
No, I think that's cheating.
All right. Fair enough.
And you know what? I don't think it's dangerous enough. I think he should stand on the chair. So, you guys think on the chair? Yeah, okay. Chair, okay.
Hey, go big or go home, right? A little bit more.
Totally untested. Okay. Yeah.
All right, you ready?
Okay.
Hey, remember, it's my face on the line, not yours, right? Here we go.
Oh, careful.
Almost fell over.
Oh!
All right, so what happened?
3.
I think it was close enough to 3. I could feel the wind on my face. Was it about that far? About that far? Actually, I was a little worried because when I released it, I almost fell over, so I was kind of careful there.
Yeah.
Okay. Did I? Okay, so here, let's go to the next slide now. Here's the thing, though. You were supposed to worry about why this was going to happen, right? So let's focus on that. Let's look at the next question here. If you could move the slide forward here.
I'm trying.
Okay. Now leave it started. That's good. This one says, this time, why did it happen? So the bowling ball of doom stopped just before reaching my nose on the way back, right? My question is why? Was it because momentum was conserved? Was it because energy was conserved? Or was it perhaps because wind resistance and friction slowed the ball down significantly on its way back? It's actually 2, right? Ooh. Momentum here is not conserved. At the beginning, what was the momentum of the ball? 0, it wasn't moving, right? And then, of course, it changed. So momentum was not conserved, right? Energy was conserved in this case. You have an exchange between potential energy, gravitational potential energy at the start, to kinetic, back to gravitational potential, and back all the way as it comes back to that same amount at the end, basically. And the third one, what's the problem with the third one?
There is no wind.
Well, there is actually a tiny
air.
bit of wind resistance because there is air in the room, right? So the ball has to push the air aside as it moves. But what's the key word in that? Significantly. It didn't have much of an effect at all, right? You guys okay with that one? All right,
Yeah.
I think it's time for the next demo.
All right, the next demo is, it's an epic battle. Can you click on the slide? Basketball versus baseball.
Okay, so 2 common spherical objects, right? I have a basketball and I have a baseball, okay? And first, I'm going to just demo about how much they bounce the first time. So watch, I'll drop the basketball. You guys see that one? Okay? And then I'm going to do the same thing with the baseball. Baseball's not nearly as impressive here. Okay, so here's the thing, though. What I'm going to do is, instead of dropping them one at a time, what I'm going to do is I'm going to stack them. Okay? I'm going to stack them like this, and then I'm going to release them both from the same, and we're going to see what happens. So here's your question. Your question is this. I drop them in that stacked position, right? And I want you to compare the height that the basketball bounced on its own, so this height, with the height that the baseball will reach when I drop them in the stacked position. Okay, you guys got that? So, when I drop them in the stacked position, the baseball will be significantly lower, slightly lower, about the same as the basketball bounce on its own, slightly higher, or significantly higher. So what happens here, the basketball bounces about that high, I'm going to stack them and release them, and now the question is, how high does the baseball go? Right? So you guys ready for this? Okay, hopefully this is not going to hit me in the face here. Right? So here we go. You ready? Here we go.
Ooh.
So what was the answer here? Yeah, the answer here was 5, right? Significantly higher, right? All right, how about your reasoning, though, now? So let's go to the next slide here. Click on the slide there. Okay, so now I want to know why. So it obviously went significantly higher, but now I want to know why did that happen? Is it because the baseball has less mass? The baseball is more dense? The basketball has less mass? Or the basketball is more dense? What's the reason it happened this time? What do you guys think? Okay, so 75% of you say the baseball is more dense. I got some bad news for you. While that is a true statement that the baseball is more dense, that's true, that's not what matters. What matters in this case is actually how much mass it has, right? So the big thing here is, which of those 2 objects is actually heavier? Do you guys know, baseball or basketball? The basketball is actually significantly heavier, okay? But it's actually less dense. So the statement the baseball is more dense is true, okay? But that's not actually the reason. What matters is the ratio of masses. This is what's known as an elastic collision, and the ratio of masses is what matters. These have about a mass ratio of 3 to 1, and you probably didn't notice because the baseball flew way up in the air, but the basketball essentially stopped. It didn't keep bouncing. And so it transmitted essentially all of that original potential energy into the baseball. Okay? All right.
Okay, fuel.
So thus far, Kate has been able to pick on me quite a bit. So Dr. Sekula has been picking on me. This time it's my turn to have a little bit of fun. So this one is called the balance bracelet. And for this one, we're going to need a volunteer from the audience, someone who feels pretty confident about their balance and wants to try it out. How about over here? Let's try over here. Let's see how you're doing. So we're going to do it.
Yay, thank you.
We're going to do a little balance test. If you could just stand here. Now, what I'm going to ask you to do is actually stand on one leg. Okay? And what you're going to do is you're going to put your arms flat out to the side. You're going to stand on one leg. And I'm just going to come along and push on one of your arms. And your goal is to keep your arms flat, like that, and also keep your balance. So when I push on your arm, don't just drop your arm. That's cheating. You got to hold it up, okay? All right, do you want me to push? I'm going to push over here because you got this leg on, right? So here we go. I'm just going to take 2 fingers. I'm going to come to your arm, and I'm just going to push slightly and maintain your balance.
No, no.
Hopping is cheating. Oh, okay. All right. Here's a challenge. Okay, same thing. You want to try the other side this time? You got your balance? Okay, arms up, flat. Okay, I'm just going to push a little bit. Try and maintain your balance. Okay. Okay? All right. Well, the good news is this is a hard task, but I brought with me the magic USAO Drover bracelet. Okay? And I want you to put this bracelet on because I'm going to tell you that this is really going to help your balance. Okay? So put that on. Okay? We're going to do the same thing again now. All I did was give you the balance bracelet. Go ahead, lift up one leg. Okay? And I'm going to come along and I'm going to push again. Hold your balance. You ready? You got to hold your arm up. There we go. Hold it flat. Don't let me push it down. There you go. You're much better at it this time. How about if I... How about the other leg? Let's try the other
magic.
leg. You seem to be much better at this time. So again, hold your arm up straight.
There you
go. Okay, I'm going to push again. Why are you so much better this time? All right. Thank you very much. You did a good job.
That's good, yeah. Thank you. Thank you.
All right, so let's look at your question here, right? This time we're jumping over. Let's go to the next one. We're jumping over. We're just going to ask you about why, right? You've already seen the demo, so there's no need to predict what's going to happen. I want to know why this happened, right? So was it because maybe I pushed at a different angle the second time? Was it because maybe if you watched I pushed at a different location the second time? Was it maybe adaptation? Was it just the fact that she got to practice the first time, she got better at it? Was it because the bracelet changed their center of mass? Was it perhaps because the bracelet is ionized? Or perhaps because the bracelet is magnetized? It is the magic USAO Drover bracelet, so it does have some special properties. Okay? So the key is this, right? I'm going to have Kate do a little balance here, right? The key is this. Your center of mass is right around your belly button, okay? So if I push away from your belly button, so for example, when I push, I'm going to push down, but I'm going to actually push away. And when I do that, it's very easy for me to tip her over. But if instead of pushing down and away, I push down and towards, then I can pretty much lean on her because I'm pushing towards her center of mass, and that keeps her balanced, right? So that's the idea here. So has anyone seen some of these magic bracelets that are for sale? Have you guys seen these online? Balance bracelet, ionized bracelet, power bands. If we go to the next slide here, there's quite a few of these out there. Some of them are called Q-Ray, Ion Loop, iRenew, Power Band Balance. And they make claims like, well, they're ionized, so it improves your balance, or they're good for your health. They have restorative properties, things like that. So can anybody think of a time that you've actually acquired a significant charge? I'm just going to deal with the ionized one here. Ionized means you acquire a lot of electric charge, right? Has anybody been significantly charged in their life? Actually, I'm willing to bet most of you have, right? Especially in the winter time. What am I talking about? I'm talking about static electricity, right? In the winter, you're on carpet or something like that. You go and you touch like a doorknob or something, what happens? You get a little shock, right? So the big idea here is that if you acquire too much charge, as soon as you touch something conductive, you'll dissipate most of that charge, right? So what I'm going to show you here is I'm actually going to demonstrate this to you. And Dr. Sekula has had so much fun with me, it's my turn to have a little bit of fun with her. And I'm actually going to electrocute her a little bit here. So, so what you see here is what's known as a Van de Graaff generator. And this is basically just a giant static electricity generator. Okay, there's a little belt in here. When I turn it on, it's going to spin, and it's going to build up charge. And you also notice that she's standing on a plastic stool. So she's insulated herself from the surrounding area so that she can actually build up a charge. Okay? We're going to turn it on. She's going to have her hands on it, and she's going to start to build up a charge. And then once we get enough charge on her, I'm going to bring over this metal sphere, which is grounded. I'm going to touch it to her elbow. And if you watch real close, when I touch it to her elbow, you'll actually see the charge arc across and touch her. Feeling like you're building up a little bit? Maybe? Yeah. All right, let's see if we can get a spark on her arm again this time. Thank you. You can bring the lights back up. Thank you for being such a good sport. All right, if we go to the next slide. So what's my point in doing this? Well, basically my point is this. If you've seen these out there, there's sports figures that endorse these, right? There's celebrities who come on and endorse these and say they help. But these are dubious products, right? Just because you don't understand how something works or they use words like quantum or ions or magnetized doesn't mean it works, okay? And if it was ionized, any charge you built up would quickly be dissipated as soon as you touch something, basically. And even if you don't believe me, I took all these quotes from the actual website of these products. So if you just read what they say about their product, probably don't want to shell out money if you think it's going to improve your balance, right? So one of my favorite is the one at the bottom. There's no assurance it can work for everyone, right? Well, if there's no assurance, why would I buy it, right? Does not claim a medical benefit, right? So you have to be very careful about these things. If you guys have bought these things, if it's just decorative, fine, great. If you like it as a fashion statement, great. But if you're thinking it's really going to help you or improve your balance or athletic performance, you probably wasted your money. Yeah, I'll ionize you for free anytime you want.